Hi everyone, in this video I will show you how to create a real-time animated sword trail in Blender. Creating this effect is a very simple process that we will learn through two main steps. First, the creation of the texture and shader, and then the rigging and animation of the trail. Only the sword motion needs to be animated, and will generate the trail fixed based on this motion. Let's get started. Creating the trail mesh will be super easy. I already have my sword object and I will simply add a plane. I will rotate it toward front view and apply the rotation and scale pressing Ctrl A. I will then move it in object mode so that it matches more or less my sword shape. Then in edit mode I will make it slightly taller so that it covers the blade. I advise you to make it slightly taller than the blade because a part of it will be masked. The cool thing is that by default when you add a plane in Blender it's already unwrapped. So we are done creating our UVs. In edit mode I will press Ctrl R to create two loop cuts. I think going above is a bit overkill, so two loop cut is way enough to get a smooth trail. And the cool thing is that the UVs are updated. Then we need to create a new material, and since I want it to be transparent, in the material setting I will switch it to alpha blend. I don't want it to emit any shadow, so then I will switch the shadow mode to none, and we will keep the back face culling disabled because if you enable it, then the shader will show only on one side. We can go to the next step and create our first mask. I'm working with Blender 292, but I guess 2.9 will work the same. In my 3D viewport I've pressed Ctrl Tab and I will switch to texture paint mode. In the texture slot I will add a new base color texture and set it to black. I will keep it at a 1K resolution. I will then go into the image editor and switch to paint. In the lowest part of the painting tool panels, I will open the tiling option and enable X and Y. Then I can open my texture library and select the sword trail base color. With the tiling option, I can now paint seamless textures. You may have to experiment a bit, but the method to paint the flame is very simple. I start by painting random broad shapes with the standard brush using pressure sensitivity for both the radius and the strength. Don't try to paint any flame shape yet, just paint slightly curved horizontal lines. Then, using the finger tool, just push a bit the black into the white and the white into the black. The trick here to get a good result is just to change the size of your brush oftenly, pressing the F key. This is a pretty simple process, but if you fail at first, just restart again. This is the first time I'm using this method and it took me 2 trials to get to a good result. Keep it loose, you don't need to add a lot of detail because this is going to be moving so we won't see it clearly. I will save it sword trail mask 01. From there, let's open the shader editor. We can get rid of the principal BSDF, and with my texture selected I will press Ctrl T to create a texture setup using the Node Wrangler add-on. As explained in the beginning, we will create a transparent material, so we need a mix shader to mix a transparent shader and an emission shader. We will plug the transparent shader in the first slot and the emission shader in the second slot. Make sure you are using the UV as coordinate and Ctrl Shift to click the texture. We can see our fire mask texture. If you don't see it, make sure you are in Look Dev shading mode. Let's plug our texture into the mix shader as a factor and Ctrl Shift to click the mix shader. Now I like to add a bit of distortion into my flame texture. You can revise the tiling and size of the pattern using the scale input. Don't use the Z-scale because the UVs are two-dimensional. To create the distortion we will simply add a noise texture. If we Ctrl Shift to click the mapping node, you will be able to see the UV coordinates. It's a simple gradient mixing red and green color. The green is the y-axis, the red is the x-axis. Since our plane is rotated, they might not be aligned with world space, but we don't care. The only thing we have to care is that our noise texture is also made of color, So if we mix those two together, the red and green color of our noise will influence the coordinates of the flame. So here the distortion is kind of overkill, but as I reduce the factor, I will get less distortion. The scale of the noise is also pretty important. We want to have a broad noise, so a scale of 2 is way enough. And if we now play with the X location of our flame texture, it will kind of flow on the plane. So you have the base principle on how we will create the effect. I can now regroup my nodes and move on to the second texture. And don't worry if you don't get every single node we are creating. At the end of the video, I will show you the full node setup. You can make a screenshot and reproduce it at your side. I will use the same process to create the second mask. In the 3D view, press Ctrl Tab to switch to texture paint mode, go into the texture slot, press the plus icon and create a new texture. Same size as before and still with a black background. The idea is to mask the edges of our plane. We don't need to input as much detail as on the first mask. We just need a big round gradient that will influence the opacity of our flame. Just make sure that the outer edges are pure black. When you are done, use a very large brush with a very low strength to paint the tip of the flame. It will lower its opacity and we will have a nice and smooth gradient. I will create exactly the same node setup as for the first texture. The only difference is that I will keep the scale at 1 because we don't want this mask to tile. Then I've used a couple of layout reroute items to make my shader editor a little cleaner. Then we can use a color mix RGB node to mix both of our masks and set the blend mode to multiply. I will push the mixing value to 1 and we don't care if you plug the first texture in the first slot or the second. After that we will add a couple of new nodes, a converter color ramp to be able to play with the contrast of our texture. We will use it to drive the color of our emission shader, and I will push the emission shader to 10. Then in the render option, I will enable the bloom option. Then I will add a converter map range before the color ramp. This will allow us to fine tweak our gradient if needed. Then we can edit the gradient of our color ramp from black and white to a cool looking fire tone. So now instead of animating both locations of both mapping nodes, I like to use only one value. So I will use a converter combine XYZ and then I will add an input value node. If I plug this input value node in the X value of the combine XYZ, then it's like moving the X value directly into the mapping node. But then I can duplicate this combine XYZ, add a math node in between, set this math node to multiply so that when I move my first value, it will modify both X location of both mapping nodes, but not with the same rate. This way we will have a difference of speed for both noises tiling, and it will look a little more random and natural than if we add both noise running at the same speed. Now to animate our fire texture, we just need to add a keyframe on our tiling value. Hovering upon the value, I will press the I key. With our keyframe created and our tiling node selected, I will open the graph editor, move the keyframe created on frame 0 by pressing G and X, and I will duplicate this frame by pressing Shift D and move it on frame 10. This way I have two keyframes for the tiling value. I will switch the handle to vector by pressing the V key, and now I have a linear interpolation between those two keys. When I move the second key down, I can see my tiling texture moving the right way. So I will push it down a bit, then select both keys and press Shift E and select linear extrapolation. Now our curve will be extrapolated and we can play our animation infinitely. Our animated fire shader is now done. In the UV editor, you can push and pull a bit the middle loop cuts from left to right to get a bit more distortion or acceleration and deceleration of the flames. You can also improve the distortion pattern, switching the noise texture from 3D to 4D. It will add a new input to the noise texture node called W, which is an evolution over time. So you can then use the distortion value node that we have animated, use the matte node to change its value, and plug it in between. Let's now create our rig. It will be super simple. I will snap the cursor to my sword, I will press Shift A and add an armature. I will give everything a relevant name and then I will switch the object display to be wireframe so that it will be easier to manipulate. Then I will go back into object mode, select our plane, select the first vertex and snap the cursor to it. I will go back into edit mode on my armature and add a new bone. I will scale it up just for visual purpose. It doesn't matter if you scale the bone, you don't need to scale it. We will then duplicate this bone 3 times and snap it to each loop cut we have created on the mesh. So you can enable the snapping mode and switch to vertices. When I'm done, as usual, I will give each bone a proper name. The first bone on the line will be the trail root. Back in object mode, I've selected the sword, then the armature. I will switch to pose mode and press Ctrl P to parent the sword to the sword bone. This way, no need to do any vertex painting, the sword is parented to this bone. Then in edit mode on the armature, I will parent the trail root to the sword bone. Then I will switch back to object mode, select my trail mesh, then the armature, press Ctrl P and use with empty groups. It has created a bone group for each bone on our trail mesh. And going into edit mode, we can assign each vertex group row of each loop cut to the corresponding bone. Once done, each bone will be moving one edge of our plane. And you have just finished the rig, so it's very simple. Now, to make it easier to read, what I will do is that I will reduce the size of each bone. Reducing the size of each bone in edit mode won't affect any of the deformation we've just created, and it will make them easier to identify. We can then add a subdivision modifier to our mesh and move it upon the armature modifier. And instead of using the Catmull-Clark interpolation for the subdivision modifier, we will use the simple subdivision method, so that you can then apply the subdivision modifier and export your mesh if you want to any game engine. By placing the subdivision modifier first, we will get a smooth deformation, and if you want, you can apply the subdivision modifier, and your mesh is ready to be exported to a game engine. But I advise you to keep the subdivision modifier without applying it because there are options to apply it during the export. For the demonstration, I will switch the bone display to B-bone and I will scale them so that it's easier to select them and identify them. Again, this has no influence on the deformation or on the rig functionalities. So now we are done for this step of the rigging. We just need to animate the sword. So I've hidden the trail effect, I've hidden all the bone but the sword bone, and I've made a rapid animation of the sword. Time to see our little trick that will generate the trail effect. The process is super simple. Once you have finished your animation, select the trail root bone, then trail 1, press Ctrl-Shift-C and add a copy transformation, and do it for each bone. It will collapse the trail since every bone will be one on top of each other, so the vertices of our trail will be one on top of each other. so nothing will happen when we play the animation. But the trick is to bake the animation and offset it in time. So I will select the free constraint bone, press F3, search for bake, and choose bake action. We will select only selected, visual scaling, clear constraint, and overwrite current action. Boom, all the bones have lost their constraint, but now we can move them. But now I will select all the keyframes of the bone but the first keyframe, and I will offset them by 1 frame. The idea is to offset trail 1 by 1 frame, trail 2 by 2 frame, and trail 3 by 3 frame. And we keep the first frame to avoid any popping. Now each bone is playing the same animation but with a bit of delay compared to the blade motion. And voila, we got our effect. But when the blade is rotating backward, we get strange distortion. To fix this issue, we just need to select our trail mesh and under the armature modifier, use preserve volume. Then if you want to fine tweak the trail size, you can switch from auto snap to no auto snap in the keyframe snapping menu. Now you can move your keyframe as smooth as you want or with the interval you want and make the trail shorter, bigger, whatever you want. And if you need to create another effect, just create a new animation, create the copy transform constraint, bake the animation and offset it, and you're done. There are other ways to create this kind of effect in Unity, but this method is totally relevant and reliable. And you can preview it or use it directly in Blender, so that's very cool to have your preview in Blender and the same thing in your game engine. This is the end of the video, but before we wrap up, a bit of self-promotion. This tutorial is sponsored by myself. If you want to learn all my rigging technique or if you want to create stylized character from scratch, you will find all you need on my Gumroad page. Use the code P2design and get 10% on whatever product you want. This is the end of this video. I hope you've liked it. Please like, subscribe and share if you want to support me, and don't hesitate to ask for tutorial specific topics in the comment section. I will try my best to answer your question through new tutorials video. See you!